Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study the kinetics of rigid bodies and the initial part, that is part 1. Let us begin with what is kinetics. Kinetics is the branch of mechanics, engine mechanics, which deals with the part of engine mechanics which deals with the force system, force and its motion, which produces force, the force system which produces acceleration and resulting motion of the bodies. So here in the case of kinetics, we study both force and also acceleration. Okay, motion of the acceleration. So these are the two things will be studied here in kinetics, whereas in kinematics only we will consider only motion without considering the force, without considering the cause, that is a force causing the motion. Now here the kinetics, there are three things which are very important. As I mentioned, force will be affected on a matter and leads to a motion. That's why force, mass and acceleration. So we are going to study here more in detail what is the force, what is the mass and what is the acceleration for in the case of kinetics of rigid bodies. Let us begin with the force is defined as an agent which tends to change the body from its state of rest or to keep the body in motion. Okay, and the unit, the force having the other four characteristics. Number one, the magnitude of the force and the point of application and its direction. So here there are three things as I mentioned here, but not four, it is three. The magnitude of the force. What is the magnitude? Suppose if the force is having 9 newtons, this 9 newtons is the magnitude of the force, and where to apply and its direction. Suppose if we consider a body, and the body is applying the force. The force should have the direction and the point of application. This is the point of application and its direction and also the magnitude. There are three things are required for complete definition of a force. Now here the unit of the force is an SI unit. Here it is in newtons. Okay, and whereas for CGS, force unit for in CGS units, that is the dynes. Now, what is the Newton? Newton is defined as, that is from the equation of F equal to mass times acceleration, Newton equal to 1 kg meter per square second. So 1 kg into 1 meter per square second, that means in order to give the acceleration to a mass of 1 kilogram and the acceleration is 1 meters per square second, the force required is 1 Newton. That is the meaning of definition of a Newton. Next, we consider the magnitude. Next, we have to consider the direct point of application. The point of application of a force acting in your body is that point in the body at which the force is assumed to be concentrated. That is the point of application of a force, assumed to be concentrated. Even though some cases the force, yes, we considering here is the complete weight is passing, is acting this much area, but the whole weight of the body is vertically acting downwards from the center of gravity of the body. This is the point is known as point of application, where the point which is concentrated, that is okay. Suppose the reaction is concentrated at one point, that is the R is the reaction for that weight. Now even though the weight is acting here, that certain area, but the whole area of the weight is passing through certain point and the reaction is in that direction only. This is the point of application. And the third characteristic is that the direction of the force, in what direction, along a straight line through its point of application, is force that based on the direction of the force, the body tends to move. Okay, and what direction? Tends to move left side, tends to move upwards or right side and downwards. So that is the direction of force is very, very important for the force. That's why there are three things to define the force. Number one, magnitude. Number two, direction. Number three, point of application. The next, coming to the mass. What is the mass? Is nothing but a quantity of matter combined in your body, is known as the mass of the body. Okay, mass is a which quantity? This is a scalar quantity, whereas the force is a vector quantity. In CGS units, mass is in kilogram, mass is in grams, whereas in MKS or in SI unit system, it is in kilograms, kg. Okay, the mass is a scalar quantity, whereas the force is a vector quantity. Force is the vector. Now coming to the third definition, that is acceleration. What is acceleration? Acceleration is defined as the velocity with respect to time, rate of change of velocity with respect to time, that is known as, or with respect to time means that itself rate of change of velocity of a body is known as acceleration. Now acceleration is measured in terms of meters per square second, okay, that is in SI system. And acceleration equal to, what is the acceleration? A equal to dv by dt, change of velocity by time, or d square x by dt square. Okay, it is also expressed in terms of velocity, that is acceleration. Now here dv by dt, dv by this acceleration, dv by dt means dv by ds into ds by dt. Can be also, it can be written as, now whatever here dv by ds times what is ds by dt, that is nothing but the display ds by dt is velocity. Now acceleration is in the form of v times dv by ds, or acceleration equal to dv by dt, acceleration equal to v times dv by ds, and also acceleration equal to in terms of the displacement, that is d square x by dt square. This is the acceleration, change of velocity by time, dv by dt. Now that's what mentioned here, v equal to dv by ds. Now acceleration equal to a equal to d by dt times ds by dt, or d square s by dt square. Now dv by dt is acceleration, as I mentioned, dv by dt, that is make it as a differentiate multiplied with in both the numerator and denominator with the ds, that's dv by ds, dv by ds, that's dv by ds times, what is the ds by dt? V times dv by ds. Now what about ds by dt? The ds by dt is known as rate of change of displacement, that is nothing but velocity. That's what velocity equal to rate of change of displacement, acceleration equal to rate of change of velocity. Okay, and displacement. Okay, these are all, acceleration, velocity are dependent on displacement s. The next term is known as, we are going to study in kinetics, important, that is the momentum. What is momentum equal to? It is the product of mass times velocity. The significance, the physical significance of momentum describes when the matter moves with certain motion, that body is having, or that matter is having the momentum. So having the momentum, the product of the mass of the body and its velocity is known as momentum. The momentum is a vector quantity. It is not a scalar quantity, it is a vector quantity, because velocity is in mass times velocity. Momentum P equal to mass times V, velocity. Now, what are the examples for momentum? Certain examples for momentum. Suppose when a car is moving on the road, that means it is having certain momentum. The car is having certain mass with velocity, that is m times v. The vehicle is moving. Okay, when the vehicle is moving with certain velocity, the vehicle is having mass, having velocity. This vehicle consists of momentum. So when in nature, when the mass is moving certain motion, the mass can be a vehicle, can be automobile, can be aeroplane, or can be a truck, can be a train. And also when the person is moving in two-wheeler, the two-wheeler plus that person body is completely certain mass, having certain velocity. That mass m into v, that is mass into velocity, that is known as momentum. Now let us start to solve the problems for this kinetics of the rigid body, how to calculate the force calculations, mass and accelerations, and its velocity also. Now here a particle of mass 1 kilogram moves in a straight line. Okay, it moves in a straight line, and the influence of a force which increases linearly with the time at the rate of 16 newtons per second. At a time t equal to 0, the initial force may be taken as 15 newtons. Determine the acceleration and velocity of the particle 4 seconds after it started from rest at the origin. It starts from rest, that means what? U equal to 0, initial velocity equal to 0. And here, how can we identify is it related to kinematics or kinetics? Yes, here kinematics and kinetics, there are two components are required. If we can consider that problem is related to kinetics. Suppose one is the force, another one is the velocity. If they're going to ask, that means it is related to kinetics. In kinematics, there is no force component. It is only velocity, acceleration, initial velocity, final velocity, displacement, acceleration. In those terms only, it will completely the problem will move. Then that will be. That's why those type of problems comes under the category of kinematics. Now here the kinetics. Why kinetics? You understand here the force 16 newtons, 15 newtons, and also you have to find out the acceleration velocity. How to find out? The given data, mass equal to 1 kilogram. Okay, and at the rate of decrease of force, that's dy by dt, that is 16 newtons. Yes, linearly increases newtons per second. At time t equal to 0, F equal to 15 newtons, and time t equal to 4 seconds. 16 newtons per second at time t equal to 0. Okay, and 15 newtons at a time t equal to 0, the initial velocity may be taken as, yes, this is 15 newtons, yes, at time t equal to 0. Now, we have to find out the velocity and acceleration. First, force is increasing linearly with the time, hence applied force of the particle is a function of the time, that F equal to at plus b. This is the equation. F equal to at plus b, then where a and b are constant. This is the equation. For the equation, we substitute when time t equal to 0, F equal to 15 newtons. F equal to 50, that means b equal to 15 newtons. And next, to find the value of the A, differentiate the equation 1, that is df by dt equal to t plus 0. That is a plus 0. That is df by dt equal to A. What is that A value is? 16 Newton per second. Okay. Now substituting the value of A and B in the equation 1. What is that equation? F equal to at plus b. That is F equal to 60t plus 50. Now that is the equation we got obtained. Now velocity of the particle after 4 seconds. Whatever seconds you want. After 10 seconds, after 5 seconds, after 6 seconds, if you want, substitute the time t equal to 4. That comes with force after 4 seconds. At time t equal to 5, force after 5 seconds, we can be obtained. Let us begin. Now here, F equal to m into A, another equation, that is F equal to m mass times A, that is the acceleration equal to A times dv by dt. Now m into dv by dt, that equation equal to what? 60t plus 50, that is F value. Now m into dv by dt, m equal to 1 kg, from the dv by dt equal to 60t plus 50. We know the equation. We want velocity. What is the velocity after 4 seconds? Means 0 to 4 seconds. That is integrate it. If you integrate dv equal to integral 60t plus 50 times dt. After integration, that is 0 to 4. That is 16 to t square by 2 plus 50 times t, 0 to 4. Substitute t value 4 and 0 value and subtract it. Then what happens here? That 60 by 2, that is 30 t square plus 50t, that is 0 to 4. Then what will happen? 30 into 4 square plus 50 into 4. That's what here. That is 680 meters per second. Next, acceleration of particle after 4 seconds. What is the acceleration of particle after 4 seconds? Now equation 3, that is m into dv by dt equal to 60t plus 50, where m equal to, we want acceleration. Again we have to make it. That is dv by dt, we got it. After dv by dt, we have to differentiate a rate of change of dv by dt is nothing but acceleration. That is dv by dt equal to 60t plus 50. Where dv by dt, that is acceleration equal to 60t plus 50. In that directly, if you substitute time t equal to 4 seconds, you will get it acceleration. That is acceleration equal to 60 times 4 plus 50. That is 290 meter per square second. Acceleration of a particle after 4 seconds is the velocity of the particle. But we got the equation here also, dv by dt, that is acceleration. that is 60t plus 50. But we want what? Velocity. So you have to integrate it, this velocity, that is the acceleration equation, you will get velocity. If you integrate a velocity equation, you will get a displacement. Okay. Next, the problem for the next, that is that a bullet of mass, it is related to, again, what the velocity would it emerge, how much velocity and all. Here a bullet of mass 81 grams and with a velocity of 300 meters per second is fired into a log of wood and penetrates to a depth of 10 centimeters. If the bullet moving the same velocity was fired into a similar piece of wood that is 5 centimeters thickness, with what velocity would it emerge? Find also the force of resistance, assuming it to be uniform. You want to find out, okay, force of resistance, and also how much this bullet will come out, emerge from that wood. Okay, the thickness of the wood is 5 centimeters thickness. Let us begin with the data was given here. Mass of the bullet is 81 grams. Convert into kilograms, that is 81 by 1000, that is 0.081 kilograms. Initial velocity of the bullet, that u equal to 300 meters per second, and distance traveled s equal to 10 centimeters, that is 0.1, that is a depth. Okay, and final velocity, because when it hits no, the final velocity becomes 0, that is 0. Now here, that is, we know the relation, that is v square minus u square equal to, we know the 2as. Why negative sign? It is due to retardation. When it enters piercing, acceleration will be reduced. That takes place retardation. Substitute v and u here, and acceleration are to be calculated, that a equal to 45,000 meters per square second. V value 0, u equal to 300, negative times 2 times a, s is the 0.1, that is the meters. 0.1 meters. Now acceleration is 450,000 meters per square second. Now what is the force? That is force equal to mass times acceleration. What is the mass? 0.81 kilogram times 450,000, that is 336,450 Newton. That is the force of resistance offered by wood to the bullet. Now next, how much the bullet emerges from that wood. So velocity of the bullet with which the bullet will come out of from a piece of wood of 5 centimeters thickness. This initial velocity is u equal to 300 meters per second, and the acceleration, that is a retardation, that is retardation equal to 450,000 meters per square second. The distance traveled here, the thickness of the wood, that is 5 centimeters, 5 by 100, that is 0.5 meters. Now we know the relation again, v square minus u square equal to negative times 2as. Okay, that is v square minus u, that is initial velocity 300 square minus 2 times a. What is that a here? 450,000 meters per square second times s is 0.05. After getting here the final velocity with which it emerged out, the emerging out is, that is 212.132 meters per second. That is velocity with which it comes out, 212.132 meters per second. Alright, that is v equal to, this is with which the bullet comes out, emerges from that wood. The thickness of the wood is 5 centimeters. Okay. Now here, there are some of the things here we are very important. We are already calculated how many problems. Here we calculated few models which are related to kinetics of rigid body. Now in kinetics of rigid body, especially that is a force component and mass and acceleration component. Now here there is, when it is for kinematics, what are the equations of motion for kinematics is, for equation of motion for kinematics, that is we use here v equal to u plus at, and v square minus u square equal to 2 times as, and one more thing is that s equal to ut plus of at square. These are the three equations of motion for kinematics. But whereas for kinetics, F equal to mass times acceleration, this acceleration A equal to whatever acceleration, A equal to dv by dt. Okay. A equal to dv by dt. Now whatever V equal to ds by dt. Substitute here that A equal to d square s by dt square. Now mass times acceleration, F equal to mass times d square s by dt square, or m into dv by dt. These are the various equations of motions. Now the problems which were calculated here, this is the problem in this related to the bullet having a mass of 81 grams and velocity initial, the velocity of that bullet is 300 meter per second. And here where we are penetrating into the wood, and the depth of the wood is 10 centimeters. The bullet moving the same velocity were fired into a similar piece of wood, but the similar piece of wood, the thickness of the wood is here, it is 5 centimeters thickness. Then at that time, with what velocity it comes out? Here, initially here, the depth penetrates to the depth of 10 centimeters. At that time, final velocity becomes 0. Now, how much now? Whereas for the wood with 5 centimeters thickness, with what velocity it comes out? So this is the problem related to the data given here: mass, initial velocity, final velocity. And to be calculated here it is, there are two components are to be calculated. One is the force component, that is the force of resistance, and another one is the what velocity, with what velocity would it emerge, it comes out, that is the final velocity here. That's why here the force of resistance, that F equal to mass times acceleration, that is the first objective, and the second objective is the final velocity Vf. So that is the problem here. And coming to another problem which we use here. In this case, are to be calculated, determine the acceleration and velocity of the particle 4 seconds after it started from rest at the origin. Now here, what is the data was given? Mass, and also df by the influence of the force which increases linearly with the time at the rate of 60 newtons. This df is increasing with respect to time, that is df by dt is 60 newtons. That is the rate of change of force. Okay, how much with respect to time? That is 60 newtons per second, that is Newton per second. Okay, Newton per second load stiffness equal to load per deflection. There is also Newton per meter. Here it is stiffness is Newton per meter. Here the value is dv by dt is 16 Newton per second. Now at a time t equal to 0, the initial force may be taken as 15 newtons. Okay, and we have to find out the acceleration velocity of the particle. Now here, one more, let me introduce. Suppose if the only force is acting one-sided, suppose the force is acting on the body, that is F, it is under motion in the direction. In order to keep it rest, we have to apply equal force in opposite direction. That force is known as inertia force. That inertia force is also in terms of m into a. Now F minus ma equal to 0. This F minus ma equal to 0, this principle is known as D'Alembert's principle. What about this ma? This ma is the D'Alembert's force or inertia force. Inertia force or D'Alembert's force. Okay, F minus ma. This D'Alembert's principle, okay, when the F minus ma equal to 0, the body is in dynamic equilibrium. Okay, whereas another equilibrium point, that equilibrium is known as static equilibrium. What is the static equilibrium? The static equilibrium, for that equilibrium conditions we are going to apply, that is sigma fx equal to 0 and sigma fy equal to 0 and finally sigma m equal to 0. Here the sigma fx, that means algebraic sum of all horizontal forces equal to 0, whereas sigma fy, it is in vertical direction, algebraic sum of all vertical forces equal to 0, whereas m for moment, that is algebraic sum of all moments equal to 0, momentum. That means if the body satisfies sigma fx equal to 0, sigma fy equal to 0, sigma m equal to 0, then the body is 100 complete static equilibrium. If sigma fx is not equal to 0, sigma fy equal to 0, sigma my equal to 0. That means here vertically there is no motion, there is motion in horizontal direction, and momentarily there is no rotation. Or if sigma fy equal to 0 and sigma fy is not equal to 0, sigma fx is not equal to 0 and sigma m equal to 0, that body having no rotation, but it is having horizontal motion and vertical motion also. If both 3 are equal to 0, 3 are not equal to 0, then the body is moving in horizontal, vertical and rotation also. Okay, it is not in equilibrium. In order to maintain equilibrium, all things sigma fx equal to 0, sigma fy equal to 0 and sigma m should be equal to 0, then the body is completely in static equilibrium. Now coming to dynamic, why static equilibrium we consider? Here also we consider the forces in x, y, z directions. Okay, but the body is completely zero. There is no motion here. Okay, there is no completely in the state of rest. Whereas for that is f minus ma equal to 0, that means the force which is acting, external force minus inertial, that is a sum of algebraic sum of external force and inertia force equal to 0, then the body is a dynamic equilibrium. Here, why is the dynamic equilibrium? Mass times acceleration. There is an acceleration component here. That's why it is a function of time. When the system is under function of time, it is in dynamic. When the system is not under the function of time, it is in static, stagnated. Okay. Thus, here it is dynamic. This principle is known as D'Alembert's principle. So, what are the application of D'Alembert's principle? Where to use the D'Alembert's principle? Applications are when the body is moving on inclined plane. When the body is moving inclined plane, what is the force? Or when the person is sitting in the lift, is moving up, when the lift moves upwards, what is the effect of that acceleration? What is the acceleration of that lift? When it is moving downwards, what is the acceleration? Okay. And some of the things, these are the applications. And one more thing, D'Alembert's principle applications such as rotating wheels. For example, there is a rotating wheel is there. When it rotates, equal weights on left side and right side, that is W1 and W2. It is having certain motion. Then what is the acceleration? We'll consider it. What is the acceleration of weight W2? So these are the various examples related to the application of D'Alembert's principles. Okay. Now, let me summarize in this session. Okay, in this session, we started with what is the kinetics, definition of the kinetics. Next, we got to know the definitions which are required to understand the kinetics of rigid bodies, such as force, mass, and acceleration. When the body is under kinetics, the force should be considered. When the force is applied on the mass having certain motion, that's why force, mass, and acceleration. The force, in order to, the characteristics of the force is, one is the magnitude of the force, another one is the direction, and the third one is the point of application. And the mass, the units for force, in the case for CGS units is the dyne, and in SI units is Newton. 1 Newton equal to 1 kg, 1 meter per square second. That means the Newton is the force required, force applied on a mass of 1 kg, which is to give which moves in the acceleration of 1 meter per square second. That is the Newton definition. Next, what is the mass? The mass is nothing but a matter, but actually this mass having a different effects. Okay, when mass is moving horizontal direction, having certain linear acceleration, that is mass times F. If the mass is moving upwards, okay, that A becomes gravitational acceleration. Okay, and acceleration is the meters per square second. So by using F equal to mass times acceleration concept, we solved some of the problems in this session and calculated the acceleration and velocity of the bodies when they are moving certain magnitudes of forces. Okay, these are the references were followed here. R.S. Kurmi, R.K. Bansal, R.C. Hibbeler, B. Johnston, Hibbeler, etc. These are the references. Okay, we can wind up the session for this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.